Hi, this is Ms. Fitzmaurice. So in this video, I'm going to tell you about position time graphs. Okay, so by the end of this video, you should be able to look at a position time graph, and when you look at it, you should be able to decide whether something is going forwards or backwards, okay? The second thing you should be able to decide is whether something is going at a constant speed, and this is just from the shape of the graph, or is it accelerating? Okay, and accelerating, I just mean the speed is changing. Accelerating. Okay, so is it speeding up or slowing down? Okay, and whether it's going towards or away from the origin. Okay, and by the origin, you'll see this word pop up a lot. It's basically where we decide to draw our zero. Okay, the second thing that you should get from this video is how to find like a number 4 position. Okay, that should be pretty easy. You just read it off the graph. Okay, the second thing is velocity. And there are going to be a couple of types of velocity that you need to know about. Okay, so our graph is going to look different depending on the type of motion. Okay, so we're going to start with something really simple, and this is constant velocity motion. Okay, so right here we have SpongeBob. You can see my beautiful drawing skills, and I can move SpongeBob back and forth. And SpongeBob lives in a pretty boring world where it's basically just a number line, and he can only move back and forth. Okay, this number line represents the distance, and for distance, we're going to use x. Some people use d, some people use s, but we're going to use x. And let's say that SpongeBob is moving around at a constant velocity. Okay, so maybe he starts out at the 3, and 1 second later he's at the 1, and 1 second later he's at the -1, and 1 second later he's at -3. Okay, so again, he's starting out at 3, a second later he's at 1, then at -1, then at -3. What I want you to do is I want you to draw this graph that I've drawn, so the xt, and I want you to try to draw what SpongeBob's motion should look like. Okay, so pause this video. In your notebook, try to draw what you think the graph should look like. Okay, so now that you've done that, we have to think about how to make this graph more specific. I said that our time was in seconds, so I'm going to put seconds over here, and I told you before that these numbers were meters. Okay, so SpongeBob at time equals 0, he started off at 3 meters. Okay, 1 second later, so I'm going to draw some seconds on my time axis. Okay, 1 second later he was at 1. So we're going to have another dot right here. And a second after that he was at -1, and then at -3. Okay, and if I was good at drawing straight lines, when I connect the dots, I should get a straight line. Okay, so imagine that I'm good at drawing straight lines, but the gist is that because it's constant velocity, we have a straight line. Okay, because SpongeBob is moving backwards, and by moving backwards, I mean he's moving from positive Okay, he started out right here to negative. If you look at our line, we have a negative slope. Okay, so once again, just to summarize, we have constant velocity gives us a straight line. Okay, and then the second thing that we have is that if our slope is positive, we're walking forwards. Okay, if our slope is negative, SpongeBob is walking backwards. Or to the negative direction. Okay, so the second thing that we have to consider is if SpongeBob is not moving at a constant speed. Okay, so what I mean by this is instead of just waltzing along straight like that, maybe he starts out really slowly and then over time gets faster and faster and faster and faster and faster. Okay, so say he starts out at 0. Okay, and he starts out slowly. He gets faster and faster and faster. I'm not going to give you specific numbers. Okay, that's called acceleration. Your velocity is changing. Okay, but if that happens, and you start at 0, what you're actually going to see is a parabola. Okay, so if you have constant acceleration, and I'm just going to write A for acceleration, then you have a parabola. Okay, and overall, if you have positive acceleration, your parabola, and this is just a cheap trick to remember this, okay, your parabola is going to look like a happy face. Okay, if you have negative acceleration, your parabola of position time, doesn't matter where the person starts out, is going to look like a sad face. Okay, so here's where I want you to test yourself. I have this graph right here. Okay, it's a position time graph, and I want you to think about if SpongeBob walking around were to make this graph, what would SpongeBob have to do? And what I've done for you is I've broken his motion up into little time periods. Okay, so the first time period is from 0 to 10 seconds, then to 10 to 15 seconds. It looks like 15 to 30, 30 to 40, and 40 to 55. Okay, so take a minute, pause this video, sketch this graph. It's not important that you get the numbers down, but I want you to get this shape. Okay, so when is it positive? When is the slope positive? When is the slope 0? When is the slope negative? And when is the slope, when is the actual position below 0? Okay, so now that you've taken a second and written down what you think SpongeBob would have to do to make this graph, let's go over it. Okay, so in time period 1, okay, so right here between 0 and 10 seconds, okay, it looks like SpongeBob starts at 0 meters. Okay, and then because his distance increases, okay, his position is getting bigger, he's walking forwards for the rest of that time. Okay, and because it's a straight line, and you look at this graph and you realize it's totally straight lines, it's at a constant speed. Okay, then we get to 10 seconds, and at 10 seconds, SpongeBob is 60 meters. And then it looks like he's at 60 meters, and 60 meters, and 60 meters. So in this second time period, he's really standing still. Okay. Now, right here at 15 seconds, his position starts to decrease again. Okay, so if it's decreasing, he is walking backwards. I'm just going to say BWS for backwards. Okay, and then he's walking towards our zero, or towards our origin. Okay, right here, if you were walking on my number line, okay, at 30 seconds, that's where he gets to the zero. And then he keeps walking in the same direction. He's still walking backwards. Okay, but he's now walking, he's getting further and further away from zero. So in part 3, he was walking this way, then he got to zero, now he's walking away from it. Okay, and then finally, at 40 seconds, he turns around, he starts to walk forwards again, and he's going towards zero. Okay, I apologize for my terrible handwriting. I am getting used to this tablet, but hopefully you can hear what I'm saying. Okay, so here's the same graph again, and now I'm going to show you how to find SpongeBob's velocity. Okay, so the definition of velocity. Velocity is like how fast you're going. Okay, and if x is your position, it's your final position minus your initial position divided by the final time minus initial time. Okay, you might have seen this symbol in chemistry, but whenever we're saying final minus initial, we can draw a triangle, and it just means change. Okay, so I have delta x divided by delta t. Okay, and if you notice, this formula looks a lot like the one you know from math, y2 minus y1 over x2 minus x1. Okay, and actually, x minus x naught is the rise, and this is the run, t minus t naught. So if you want to find the velocity, okay, how fast something's going, and you have a position graph, okay, and position is our x, then you have to find the slope. Okay, and just to make sure you guys are good with finding slopes, let's practice a few points. Okay, so I'm going to draw a few points on this graph, and I want you to tell me the velocity at those times. Okay, so the first time I want the velocity is right here. I should draw a yellow star at 5 seconds. Then I want the velocity right here. Okay, I want the velocity right here, and I want the velocity right here. Okay, so take a minute. I can name these guys. So let's call this A, B, C, and D, and I want you to try to find, for me, the velocity of SpongeBob at these starred points. Okay, so you're finding the slope. Okay, so let's look at A. And remember, slope is always rise over run. And if I want the slope anywhere on this stretch of line, I can take any 2 points on that line. So I'm going to take the 2 easy points. Okay, I'm going to take 60 and 0. Okay, looking at this, my rise is 60, and the run right here is from 0 to 10 because we have 10 seconds. Okay, so I can go ahead and I can calculate that. I want to remember that I have units, so it's 60 meters, that's the rise, divided by 10 seconds, and my velocity is equal to 6 meters per second. Okay, for B, I'm on this piece of line right here, and if you look at it, you realize there's no rise. So we have 0 divided by 5 seconds, and the velocity there is just 0. Okay. For C, again, I can take any points along this line. So I'm going to pick some easy points. Okay, I'm going to pick, let's see, this point right here, so it's at 20 and 40, and this point right here. Okay, because it's going down, my rise is from 40 to 0, so I have negative 40, and the run is from 20 to 30, which is 10. So what that means is my velocity is negative 40 divided by 10, which is equal to 4 meters per second. Okay, finally, part D, we do it exactly the same way. The velocity is, the rise, so we're going from negative 40 to 0, so the rise is 40. The run right here from 40 to 55 is 15, and 40 divided by 15 is a number that I can't do in my head right now, but hopefully you get the idea. You could plug that into a calculator and you get a number. Alright, so here's another example, and I've starred the places I want you to find the velocity. I want you to find the velocity for me at 1 second, at 4 seconds, and at 15 seconds. So pause this video for a minute, try to make sure you can figure out the answers for yourself, and I will give you the answers in just a bit. Okay, so once again, we only care about the piece of the graph that our star is on. Okay, so for 1 second, we only care about this line right here. You can see with your eyes, hopefully, that the rise is 0. So my velocity is equal to 0 divided by, doesn't matter what the run is, because 0 divided by anything is equal to 0, and it's just 0 meters per second. Okay, for 4 seconds, okay, we have a rise of negative 3. Okay, my run right here is 3. I just picked the 2 easiest points on this line. So I have negative 3 divided by 3, which is equal to negative 1 meters per second. Okay, and finally at 15 seconds, it looks like I'm going to pick these 2 points. Those are the easiest ones on this line. The rise, it goes from negative 6 up to 2, so it looks like the rise is equal to 4. The run is equal to 2, and 4 divided by 2 is 2 meters per second. Okay, so average velocity. You probably saw this equation when you were doing your summer homework, but average velocity is also delta x over delta t, so that's final minus initial position divided by final minus initial time. Okay, so for example, if I want the average velocity from 1 second, so at 1 second we're right here, to 3 seconds, we do almost the same thing. So even though this is not a straight line, and we can't find the slope at any one point, we can say that V average is the change in position. Okay, so it's x minus x naught. This little naught just means initial, divided by t minus t naught. Okay, my final position, it looks like, if I draw this over, is 3 minus my initial position, which is 11 divided by my time. So my final time is 3 minus my initial time, which is 1. Okay, 3 minus 11 is negative 8 over 2. So my average velocity is negative 4 meters per second. Okay, so if you have something that is not a straight line, or if they ask the average velocity, don't worry about what line it's on. Just take the final position, the initial position, the final time, and the initial time. Okay, and then the last thing we're going to talk about is what if you want the instantaneous velocity rather than the average velocity. So if I wanted, this is my position time graph, this is how SpongeBob is moving around his little world, and I want to know at 2 seconds, how fast is he going? Okay, what I can do is I can draw this line that your math teacher probably calls a tangent line. Okay, so it's a line that only touches once, and I can find the slope. Okay, so we'll practice this a few times. I don't want you to worry about it too much tonight, but the steps, if you need instantaneous velocity, there are multiple steps. Draw a tangent line. Okay, and then instant velocity, I'm just going to abbreviate, is the slope. Okay, so thanks for listening to this video, and I hope you have a better idea of position time graphs.